All right, so I'm going to do number 5, and you're assigned number 6. So they're very similar. And along the way, I'm going to show you a little bit of the why we're doing what we're doing. First, you would take the derivative from left to right. Whenever you do anything with a y, you multiply by dy dx. I'm going to explain in a second. So just going straight forward, the derivative of x squared is 2x. So you have a power of 2 on your number 6. So I'm just applying the power rule here. The second term, 4xy, is a product where the first term is 4x and the second is y. So I'll take 4x, which is the first, times the derivative of the second. Derivative of y is 1. Just pretend it's like an x, and then multiply by dy dx. Don't do a y prime like they sometimes do in the book, because your y's and y primes will start to get messed up together. And then the derivative of the second function is y, times the derivative of the first is 4. So look here how I've tracked everything. The first function is 4x, the second function is y. So I'm being very careful. Notice something else, I have the parentheses up. Lewis, make sure you have those parentheses up, because I have a minus sign in front and I don't want to mess things up. The last term is y squared. The derivative of y squared is 2y. I'm just applying power rule, but I've just done something with a y, so I multiply by dy dx. Again, over here, the derivative of the second function, y, is 1, but I've just done something with a y, so I multiply by dy dx. Just pointing that out, derivative of y to the 1 is 1 times y to the 0, which is 1. But since I just did stuff with a y, I multiply by dy dx. The same thing here in the last term. I've just taken the derivative of something with a y in it, so I multiply by dy dx. Why am I doing that? Well, here's the real reason. We can't think about this as we're doing a complicated problem, but when I have, for example, y squared was my last term, I'm really taking y, which is a function of x, squared. My inner function here is a y of x. My outer function is cover up the inner with your thumb and replace your thumb with an x. And the derivative of the outer is 2x, and the derivative of the inner, well, that's dy dx. The derivative of the inner function is y prime, or dy dx. So I get the derivative of the outer with the inner plugged in for x times the derivative of the inner. You're really just applying chain rule. Well, we can't think about that when we have this long, messy thing to go back and forth. So the way to shortcut that is just to say, every time I take the derivative of anything with a y in it, I'm going to have to multiply by dy dx, because it's always the derivative of my inner. The second step, only if you're asked, solve for dy dx. I'm okay with leaving it like this. You can leave it as dy dx in this messy form. I don't want to see your algebra. But if you're asked to solve for dy dx, what you're going to have to do is clean things up. So first I'm going to bring this minus sign in. And then bring all the stuff that's not dy dx to the right side. So here I have a 2x, so it's going to be a minus 2x on the right side. And here I have a minus 4y, it's going to be a positive 4y on the other side. So all I'm doing is isolating the dy dx stuff. The next step is to factor out dy dx. And see this ugly you're left behind? Doesn't matter. I'm just going to slash both sides by the ugly. So the stuff that was to the right of the dy dx just goes on to the divide by the whole thing. And that gives you your dy dx. The issue here, and I'm going to show you a picture in a second, not for this problem, but for a different problem. This is a formula for the derivative, but the y's are inside. There's a way to get rid of it, but you're not going to Georgia Tech where you're going to actually be an engineer right away. So you don't have to really worry about that right now.